All right, so here is just a quick extension from all of our algebra skills, applying those to trig expressions. So we can treat a trig expression like cosine of x in our equation just like a variable. It has a value that it's standing in place for, so we can use all of our algebra skills similarly. So let's remind ourselves of some basic things. If I want the reciprocal of 5, I'm thinking of that as 5 over 1. So the reciprocal of 5 is 1 over 5. Therefore, the reciprocal of sine is 1 over sine. And we have an identity that states 1 over sine is equal to cosecant. The reciprocal of x, that's x over 1, that's 1 over x, right? So notice we treat sine theta just like the variable x. And I got a little ahead of myself. A single trig function to represent 1 over sine would be cosecant. The reciprocal of cosine would be 1 over cosine, and as a single trig function, that is our reciprocal identity, secant. If we want to simplify x times x, that's repeated multiplication, we write that as an exponent. So if I do sine times sine, I write it as an exponent. But what's important is that our notation for trig identities, we specifically use the exponent between the function and its argument so that it's not ambiguous whether you mean this, all of it squared, or the argument squared, right? If we were to write it like the second way, this way implies the argument is squared. You have to use parentheses around the whole thing if you want it to represent the whole function squared. But we're actually going to square these functions a lot. So instead of writing parentheses every time, we just use this method of putting the square in between the argument and the function to represent squaring the entire thing. So similarly, if we use cosine times cosine, that is cosine squared theta is how you'd read that. And that indicates cosine of theta is being multiplied by cosine of theta. Now, if I multiply fractions, a over b times c over d, we multiply top times top and bottom times bottom. So that is ac divided by bd. If I have a squared times b, a squared over b squared times b over a, that is a squared times b over b squared times a, and I can simplify that because I have some common factors. Notice factors are ingredients in multiplication recipes, so there's only multiplication of variables going on in the numerator and denominator. So I notice that I have a squared over a, that gives me 1a in the numerator left over. A times a over a, 1a cancels. B over b squared has 1b left over in the denominator. So our simplified form is a over b. It is best if you can start getting in the habit of going straight here. You can write out the middle step if you need to, and if you are struggling with dropping terms or making easy mistakes, definitely write out the middle step. But if you can see, hey, that's a squared over a and b over b squared, we can simplify, go straight to a over b. Similarly, 1 over 1 is 1, and c over c is 1. So this is just c times 1 over c, anything over itself is 1. So if I have cosine theta over sine theta times sine theta, notice this is like cosine theta over sine theta times sine theta over 1. I know sine over sine is 1, so this is simply cosine theta. If I have cosine over cosine squared, there's 2 cosines in the denominator, 1 in the numerator. One set cancels or simplifies out, leaving 1 behind in the denominator. Similarly, next example, I have 1 sine in the numerator and 3 in the denominator, so I have 2 sines left over in the denominator. If I have sine over sine, I'm left with 1 over cosine in number 16. That simplifies to our reciprocal function, secant. We always want to get rid of fractions and write it as a single trig function if we're simplifying whenever possible. So if I'm dividing fractions, we remember keep, change, flip, or multiply by the reciprocal So the reciprocal of my denominator c over d will be d over c. So I have a over b times d over c. That is ad over bc. Remember, if your denominator isn't a fraction, you've got to put it over 1. So xy times 1 over w is x over wy. So if I have sine squared over cosine squared divided by 1 over cosine squared, notice we have the larger fraction. This is called a complex fraction when we have a fraction inside of a fraction. And so we take the numerator and we multiply by the reciprocal. So we have sine squared over cosine squared times cosine squared over 1. 1 over cosine squared flips to be cosine squared over 1. Now cosine squared over cosine squared is 1, so all we're left with is sine squared over 1. If we are multiplying, notice if you see this difference of squares behavior, if you see two binomials multiplied together and they form a difference of squares, they're what's called conjugates, right? You might remember the complex conjugate as an idea. When you multiply complex conjugates, you create a difference of squares. Well, if we multiply any type of real number that creates a difference of squares, that is called a conjugate. So if I multiply a times a, that's a squared, and b times a, ab, b times a times, sorry, I've done first, inner, outer, minus ab, last. So that is plus b squared. Notice our ab and ab cancel. That's because they're conjugates difference of squares. So we have a squared, and this should be negative b squared because positive b times negative b is negative b squared. So we have a squared minus b squared. Notice that difference of squares, right? So if I have 1 times 1 and cosine times cosine, negative cosine I should say, that is 1 minus cosine squared. If I were to do the inners and the inners make negative cosine and the outers make positive cosine because they are conjugates, which creates this difference of perfect squares. 1 is a perfect square, cosine squared is a perfect square. We can then use our Pythagorean identity to figure out what 1 minus cosine squared is equal to. I know sine squared plus cosine squared equals 1. So if I subtract cosine from both sides, I have that 1 minus cosine squared equals sine squared. So that is my most simplified form of 21. When you add and subtract fractions, you need a common denominator. So be sure to always get a common denominator. If I'm adding a over 1 plus b over a, I need the denominator of the first fraction to be a as well. So I will multiply by 1, also known as a over a. That gives me a squared over a plus b over a. And now that I have a common denominator, I can add the numerators and keep that common denominator. So a squared plus b over a. That's simplified. Let's do it again. Here I already have a common denominator, s squared. So I can simply distribute the negative to the entire right side. This is only one term, so I only have to make it minus c squared, but if it was c squared plus 7, I would have to distribute that negative to the c squared and the positive 7, making it negative c squared minus 7. So just be really careful with distributing your negatives. Reminder to self, distribute negative to entire second numerator.